Here's a different equation. It's not linear. It's not even a quadratic equation. It's actually a fourth degree equation. The highest power of the variable is the fourth power. That makes it a fourth degree equation. The only technique we have so far for solving this kind of equation is to look to see if the polynomial is factorable. And remember, when we factor, we always try to factor a common factor first if one exists. And if we look at those two terms, the coefficients both contain a factor of 5. And the terms also share in common x to the second power as a factor. So we can factor 5x squared out of each of those terms. That would leave us x squared minus 4. Dividing this term by 5x squared, we get x squared. Dividing minus 20x squared by 5x, we get minus 4. Now we look at that binomial to see if we can factor it further, which I trust you can recognize this is the difference of squares, x squared minus 2 squared. And x squared minus 2 squared would factor into x plus 2 times x minus 2. And we have completely factored that original binomial. Now we can see what values of x could make this left side become 0. Well, if x was 0, 0 squared is 0. 0 times anything is going to be 0. So x being 0 would be a solution. In this factor, if x was negative 2, negative 2 plus 2 is 0. 0 times anything makes 0, a second solution. And from this factor, if x was positive 2, 2 minus 2 is 0. 0 times anything is 0, my third solution for this equation. So when you have an equation where the powers are higher than 2, look to see if you can factor that polynomial to produce a situation where you can analyze it and determine what values of the variable would make the left side of the equation become 0.